All right, so doing these kind of graphs, it is really tricky. So I've started writing, and I was just going to send a slide, but I think it's too confusing, so I'm going to record. So let's start with the easy things here. All right, the easy thing is the -4, right? So this -4, it's going to move the function down 4. All right, so when we think about that, instead of having zeros on the axis here, where x-axis is the kind of the 0, the middle part of this function is going to be here. So you can kind of sketch that in, or imagine it to help yourself, that that's going to be the middle part of this. All right, then we have this -4 in front. And the easy part is the 4 value. That's going to change the amplitude, right? That means that it's going to come up 4. So it's the maximums are going to occur up here at this point. That's what that 4 is going to do. And the minimums, you kind of had it. The minimums are going to come down and occur here at 8. So we kind of have those two things sketched in there, the top and the bottom of this graph. Now, these, I have it in green, this negative here and this negative here. This negative would have flipped the maximums to the minimums, and this negative would have flipped it across the y-axis. But these two mean that this graph, they kind of negate each other. So this graph looks the same as this graph. When there's a negative in there both, we can just, they're going to look exactly the same. You can go look on Desmos if you want to prove it to yourself, but they do. They look the same. So we can kind of just say we're graphing 4 sine of 2x minus 4. All right, but now we still have to deal with the period. So the value that's with the x here inside the sine, right? Inside this sine function here. This is going to change the period. So the period of pi is always 2 pi divided by b. Well, b equals 2 here, so we have 2 pi divided by 2, and that equals pi. So that means that every pi, right, or sorry, 180 degrees, we're going to have this function repeating itself. So it means that by the time it gets to 180, right, it's got to have a pi function, or sorry, sine function starts at a 0, goes to a max, goes back to the 0, goes to a min and a 0. And it's going to do all of that by the time it gets to 180 degrees, or if we want to work backwards, negative 180 degrees. All right, and what I do, what really helps me, is if I just take that value and I start counting. So the first one is occurring at 0, right? It's actually at 0x. We're going to get a 0 of the function. The max has to occur at pi over 4, whatever the period is of fourth. The next 0 is going to occur at 2 pi over 4, but that's the same thing as pi over 2, right? That's 90 degrees. The next one's going to occur at 3 pi over 4, and the last one's going to be at 4 pi over 4. All right, so now, or just pi, right? So now we know that by 180 degrees, we're already back here. Okay, and we know a maximum is going to occur at pi over 4. So we just have to, Desmos is kind of hard because, or not Desmos, IXL, you have to think in degrees. So pi over 4 is 45 degrees. So that's going to be halfway between this 90, so halfway between here. And we might not be able to very easily put this on with the this little circle thingy. It might not come on so well. And sorry, my slide cue. So at halfway, it's going to, or at pi over 4, it's going to be a maximum. So at pi over 2, that's 90 degrees. Well, it's got to come back here to be on the axis. And then another 3 pi over 4, so that's again halfway here. It's got to be all the way down. Sorry. Okay, and now I can get a basic form. And I could keep going, right? I could just keep saying 5 pi over 4, 6 pi over 4, 7 pi over 4. Just use whatever the period is divided by 4. That's kind of your counting to where the graph goes. All right, so I hope that helps. If not, let me know.